Structural Mechanics 3, Revision Notes, Part 2, Plastic Limit Analysis. Aim and Objectives of Plastic Limit Analysis. Understand how structures can fail due to plastic yielding of materials. One more economic design. Elastic design conserves material by ensuring no stress exceeds the yield stress. Allowing some plastic deformation without structural failure leads to more economic design. 2. Plastic collapse. Excessive stress causes material points to fail, leading to section failure, plastic hinges, and ultimately the collapse of the entire structure. Introduce methods to determine plastic limit or collapse loads of simple steel structures. Key concepts. Failure mechanisms. Material point failure. Stress at a point reaches the yield stress, determined by the stress-strain curve, assuming perfectly plastic behavior after yielding. Section failure, when the stress across a section equals \sigma_y, forming a plastic hinge, plastic moment \m_p_, dependent on section shape. Structural failure, sufficient plastic hinges turn the structure into a mechanism, losing its load-bearing capacity, defined by the plastic limit/collapse load \p_c_. Plastic hinge and moment for sections. Plastic hinge, pH, the whole section yields, governed by two formulas. 1. Axial force equilibrium determining the equal area axis. 2. Moment equilibrium giving the plastic moment. Symmetric sections, neutral axis equals the equal area axis. Unsymmetric sections, neutral axis equals the equal area axis. Elastic and plastic moduli and shape factor, knowing how to compute these values for any given shape, assuming known yield stress. Theorems of plastic analysis. Unique theorem, the true plastic limit load satisfies equilibrium, yield condition, and mechanism condition. Lower bound theorem, satisfies only equilibrium and yield conditions, forming the basis for the static method. Upper bound theorem, satisfies only the mechanism condition, forming the basis for the virtual work method. Key procedures. Static method of plastic analysis. Gradually increase the load until the structure becomes a mechanism. Equilibrium, obtain bending moment distribution at different stages. Yield condition, introduce new PHS when necessary. Mechanism condition, identify the collapse load when the structure becomes a mechanism. Approach the collapse load from the lower side, drawing correct bending moment diagrams, and identifying correct PHS. Virtual work method. Simple to use, considering all possible mechanisms. Mixed method. Combine static and virtual work methods. Replace redundant supports with unknown reaction forces to make the structure statically determinate. Draw bending moments using reactions. Identify PHS to make the structure a mechanism. Use equilibrium equations and pH conditions to determine corresponding load and reactions. Key structures. Beams. Can use all three methods, static, virtual work, and mixed, to solve beam problems, considering statically indeterminate and continuous beams, distributed loading, and identifying pH locations. Portal frames, IN2. Use two methods, virtual work and mixed, for portal frame problems, considering independent and combined mechanisms, load combinations, cancelled PHS, and weak member locations. Gables. Similar to portal frames but includes the concept of the instantaneous center, considering complex geometric relationships. Selected outline solutions, examples and past paper questions. Example 1, identifying plastic hinges for each mechanism in beams and frames, using the static and mixed methods to determine collapse loads. Past paper 2018-19, Q2, D, E, using the static or mixed method to analyze frames, computing bending moments and identifying pH locations. Past paper 2017-18, Q3, D, using the static method to determine the critical load causing plastic collapse in a frame. These notes outline the essential concepts and procedures of plastic limit analysis, aiming to enhance understanding and facilitate the application of these principles in structural mechanics.